I will present here the strategy followed by the sailboat robot Vemos for line following. So the line to be followed is represented here. First, you have a nominal vector field, which will make Vemos attracted by his line. This nominal vector field has two parameters. The incidence angle, J infinity, which corresponds to the angle of the field when the robot is far to the line. And the other parameters is R. So what is R is the cutoff distance and corresponds to the strip where we want the robot stays. So we do not want the robot be here, but in this strip. This strip here corresponds to something like 50 meters. Now in red, it is the wind. So I can move with the software the wind. And as we can see here, if I put the wind in the wrong direction, then excuse me, if I put the wrong direction, some direction are not consistent with the wind. So the robot is not able to go upwind directly. So let me explain this. If I have the wind here, C, angle of C, there is some no-go zone where the robot is not allowed to go, it cannot follow this direction. So all these directions theta are feasible, but those ones from the no-go zone are not feasible. This condition is satisfied. If this condition is satisfied, then the robot will not be able to follow the direction theta. So the regulator to be considered is this one. First, we compute the vector field, the nominal vector field. If the condition is not satisfied, so the direction theta star is not feasible, then we compute some kind of projection on the feasible set here. Otherwise, we take the nominal vector field. And we'll see later this keep tag strategy, why it is needed. So let me come back here. First, as we can see here, the polar projection strategy will perform a projection and the robot will be in what we call a tack mode, so close to the wind, but still feasible. When it is a tack mode, the rows are represented in bold font. So when I move here, I will only obtain arrows that try to go to the line, but still being feasible. I can start some simulation. First, the simulation where everything is the feasible psi, for instance. The simulation will be like this one. So I do randomly some condition initial, and I obtain a boat that goes to this line. Now, when it is not, when the wind is not well oriented, then let me start some simulation. I obtain, if I add some hysteresis here in this strip, feasible strip, then I obtain some kind of tacking mode represented here. So I can start several, I can do several of them, simulation, and what happened is it seems to work almost all the time, but sometimes for some C well chosen, for instance this one, sorry, if I start some simulation, so here when it is green it is a direct mode, and after it switch to the tack mode. So let me start some of them. Sometimes, as you can see, it goes here in a direct mode, and so here also, and sometimes I may have some strange behavior that are difficult to find. Maybe, okay, this one is good. As we can see here, it hesitates between a tack mode and a direct mode. And here the robot is not optimal, and it takes time to switch from one to another. That's why we need a keep tag strategy, and with the keep tag strategy, he forces the tag mode, even if the nominal direction is a good one. It prefers the tag mode so that the behavior will be better and will be more optimal. So now we want to check that everything will be okay for all feasible wind. So what can we do? Just graphically, we can draw for all feasible wind, and we obtain a set of fields which is called a differential inclusion. So if some stability properties are satisfied for the for the inclusion, then it will be satisfied for all feasible fields. So now we use the interval analysis to prove the stability for the differential inclusion, and we conclude that for every feasible wind, the stability will be okay. So what is the stability? What are the stability studied here? Then first, we are able to prove that for some parameters well chosen, of course, if I am outside the strip, then the distance to the line will decrease, and this for all feasible wind. Moreover, this strip is a capture set. It means that if I am inside the strip, then I will stay there forever, and for all feasible, for all possible wind, as I can see here, with respect to some simulation, different simulation, and this for all wind, this will be the case. So here direct mode is possible sometimes. Okay, thank you for attention.